What is the single most dangerous thing in the entire universe? Well, today we're going to tackle a cosmic what-if scenario that really pushes physics right to the edge. Let's find out what would really happen if a black hole decided to pay Earth a visit.
So let's play this out. We're going to go step by step through the absolutely terrifying and honestly mind-bending journey our planet would take if this ultimate cosmic predator wandered into our solar system. Okay, first things first, let's get the biggest myth out of the way. We all have this image of black holes as these cosmic vacuum cleaners, just sucking up everything in sight. But that's not really how it works. Their crazy gravity is only a problem once you get really close. Cross that line, and yeah, there's no coming back. Here's a wild way to think about it. Imagine you could somehow crush the entire Earth down to the size of a marble. Poof, it's now a black hole. You know what would happen to the moon? Absolutely nothing. It would just keep orbiting that tiny little point in space. Why? Because from that distance, the mass is exactly the same, which means the gravity is the same. It's all about proximity. So yeah, it's not about sucking, it's about density. You take an insane amount of matter, squeeze it into an impossibly tiny space, and you get gravity so powerful it literally bends space and time around it. And that distortion creates the infamous event horizon, the ultimate point of no return. All right, let's set the scene for our story. A stellar mass black hole, basically the dead, collapsed core of a giant star, maybe a few times bigger than our sun, has just wandered into our cosmic neighborhood. And here is where it gets really creepy. We wouldn't even see it coming. Long before this invisible monster got anywhere near us, we would feel it. Its gravity would start tugging at the outer planets, a silent, invisible warning that something is very, very wrong. And as it gets closer, that gentle tug becomes a violent shove. The whole delicate gravitational dance of our solar system just starts to completely fall apart. So for Earth, what are the options? Well, none of them are good. We could get flung out of the solar system completely, becoming a frozen rogue planet drifting in the dark. Or maybe we get pulled into a crazy new orbit, swinging wildly from super hot to super cold, which would wipe out all life. Or the third option, we get captured and set on a one-way trip straight into the black hole. But here's the thing. Even before we crash into it, the danger completely changes. As the black hole gets close to our sun, gravity almost takes a backseat to a much more immediate threat, a blast of lethal radiation. You see, the black hole's gravity would start peeling gas and plasma right off the surface of the sun. This stuff wouldn't just fall straight in, though. It would get caught in a swirling, superheated vortex around the black hole called an accretion disk. And the friction in this disk would heat all that matter to millions of degrees, turning it into a blazing beacon of deadly light. This glowing accretion disk basically turns into a weapon. It would blast our entire solar system with a fire hose of high-energy X-rays and gamma rays. That wave of radiation would be so intense, it would just strip our atmosphere away, boil the oceans, and completely sterilize the planet. And this would happen long before we actually got anywhere near the black hole itself. Now, assuming any tiny part of our planet survived that radiation blast, its final moments would be the weirdest of all. This is where the planet itself gets physically torn to shreds. Scientists have a fantastic name for this: spaghettification. And it's exactly what it sounds like. It happens because of tidal forces. So the part of an object closer to the black hole gets pulled way, way harder than the part that's farther away. That difference in pull stretches you out thinner and thinner, like a noodle of spaghetti. But here's where things get really weird and kind of counterintuitive. You'd think a bigger, supermassive black hole would be more dangerous, right? But when it comes to spaghettification, that's not actually true. For small stellar mass black hole, the gravity changes so fast over such a short distance that those tidal forces would rip you apart thousands of miles before you even got to the event horizon. But for a supermassive one, like the behemoth at the center of our galaxy, the event horizon is huge, and the curve of gravity is much more gradual. You could actually cross that point of no return completely intact without feeling a thing. I mean, you'd still be doomed for sure, but you wouldn't get spaghettified until much later, deep inside. So pro tip, if you have to fall into a black hole, pick a really big one. Okay, on to the final and most mind-bending part of our planet's end. As Earth gets right up to the edge of the event horizon, the laws of physics that we know and love start to get, well, warped. And that includes time itself.
So this whole bizarre effect comes straight from Einstein's theory of general relativity. He taught us that gravity isn't really a force, it's a curve in the fabric of spacetime. Think of it like a bowling ball on a trampoline. A massive object, like a black hole, creates such a deep curve, such a deep well in spacetime, that it actually slows down the flow of time for anything nearby. And the result of this is just wild. For us, watching from a safe distance, time for anything falling in would look like it's slowing down. As the Earth got closer and closer to that event horizon, its movement would seem to just crawl to a stop, like it was trying to move through cosmic molasses. From our point of view, we would never actually see the Earth cross that boundary. We'd see it slow down, get dimmer, and then just freeze. Its final image would be stretched across the edge of the black hole, stuck there for what appears to be eternity. So think about that. From its own perspective, Earth's final journey is over in a flash. But from our perspective, it never actually ends. And this leads to one of the biggest, most profound puzzles in all of modern physics, the information paradox. What happens to all the information that made up our world? Every mountain, every ocean, every person? Is it just erased from the universe forever? Or does it somehow get preserved? It's a question physicists are still fighting over, leaving us right at the edge of one of the universe's greatest mysteries.